Artificial intelligence, AI, is a wide-ranging branch of computer science concerned with building smart machines capable of performing tasks that typically require human intelligence. AI is an interdisciplinary science with multiple approaches, but advancements in machine learning and deep learning are creating a paradigm shift in virtually every sector of the tech industry. Hi and welcome back to techloop. Make sure to push that subscribe button and the bell icon to get the latest updates when we upload. How does artificial intelligence work? AI works by combining large amounts of data with fast, iterative processing and intelligent algorithms, allowing the software to learn automatically from patterns or features in the data. AI is a broad field of study that includes many theories, methods and technologies, as well as the following major subfields. Machine learning automates analytical model building. It uses methods from neural networks, statistics, operations research and physics to find hidden insights in data without explicitly being programmed for where to look or what to conclude. A neural network is a type of machine learning that is made up of interconnected units, like neurons, that processes information by responding to external inputs, relaying information between each unit. The process requires multiple passes at the data to find connections and derive meaning from undefined data. Deep learning uses huge neural networks with many layers of processing units, taking advantage of advances in computing power and improved training techniques to learn complex patterns in large amounts of data. Common applications include image and speech recognition. Cognitive computing is a subfield of AI that strives for a natural, human-like interaction with machines. Using AI and cognitive computing, the ultimate goal is for a machine to simulate human processes through the ability to interpret images and speech, and then speak coherently in response. Computer vision relies on pattern recognition and deep learning to recognize what's in a picture or video. When machines can process, analyze and understand images, they can capture images or videos in real time and interpret their surroundings. Natural language processing, NLP, is the ability of computers to analyze, understand and generate human language, including speech. The next stage of NLP is natural language interaction, which allows humans to communicate with computers using normal, everyday language to perform tasks. Additionally, several technologies enable and support AI. Graphical processing units are key to AI because they provide the heavy compute power that's required for iterative processing. Training neural networks requires big data plus compute power. The Internet of Things generates massive amounts of data from connected devices, most of it unanalyzed. Automating models with AI will allow us to use more of it. Advanced algorithms are being developed and combined in new ways to analyze more data faster and at multiple levels. This intelligent processing is key to identifying and predicting rare events, understanding complex systems and optimizing unique scenarios. APIs, or Application Programming Interfaces, are portable packages of code that make it possible to add AI functionality to existing products and software packages. They can add image recognition capabilities to home security systems and QA capabilities that describe data, create captions and headlines, or call out interesting patterns and insights in data. In summary, the goal of AI is to provide software that can reason on input and explain on output. AI will provide human-like interactions with software and offer decision support for specific tasks, but it's not a replacement for humans, and won't be anytime soon. How artificial intelligence will work in 2021. Artificial intelligence has expanded its grip on our lives throughout the past year. Even as a global pandemic forced many data scientists to work from their homes, AI-driven innovations continued to pour from the smartest minds everywhere. AI is a centerpiece of the coming new normal in all our lives. Going forward, AI will be the intelligent nucleus of automated, robotic, and contactless processes that will protect us all from future outbreaks. With the COVID-19 crisis still in full sway, here are my predictions for the specific AI techniques, tooling, platforms, and apps that will come to the forefront in the year to come. Automated governance will become key for controlling AI applications. Rogue AI is intolerable. In 2021, enterprises will beef up AI governance across their organizations by instituting strong model assurance within their machine learning operational workflows. This will become an essential capability for ensuring that AI apps carry out their intended functions accurately while steering clear of privacy violations, demographic biases, and other adverse algorithmic outcomes. Vendors of AI governance platforms will extend their ability to deploy and manage a steady stream of assured models all the way to edge devices. Adversarial attacks will require countermeasures to protect the AI-driven economy. Resilient AI is fundamental. In 2021, AI professionals will clamor for a consensus methodology for detecting and dealing with adversarial threats to AI apps, such as edge-based computer vision systems that rely on convolutional neural networks. Many AI developers will adopt the recently released Adversarial ML Threat Matrix, an open, extensible industry framework for classifying the most common adversarial tactics that have been used to disrupt and deceive ML systems. Many machine learning DevOps vendors will incorporate this standard, especially access to their GitHub repositories for a curated repository of adversarial attacks, into their solutions. Edge-based AI will crunch neural networks down to their essence. Compact AI is essential. In 2021, AI developers will routinely prune all their models' neural network architectures, hyperparameters, and other features to fit the hardware constraints of edge platforms. Increasingly, AI model compilers are automating the compression and tuning of AI models for fast, efficient execution across myriad edge endpoints. As the tiny ML revolution picks up speed, we'll see more AI developers use neural architecture search techniques to find the most compact, efficient structure of a neural net for a specific AI inferencing task. Compression of AI algorithms down to their predictive essence will speed the movement of most AI workloads to run on the microcontrollers embedded in edge devices. Facial recognition will become a dominant AI-based contactless authentication technology. Authenticated AI is imperative. In 2021, enterprises will implement facial recognition for strong authentication in a growing range of internal and customer-facing applications. By the same token, business will increasingly avoid using the technology to inference identity, race, gender, and other attributes that might be sensitive from a privacy, bias, or surveillance standpoint. To the extent that businesses incorporate facial recognition in image, video auto-tagging, query by image, and other such applications, it will only be after extensive review by legal counsel. The regulatory sensitivity of this technology, and the legal risks, will only grow for the foreseeable future. Robotics will bring reinforcement learning into AI's mainstream. Agile AI is indispensable. In 2021, the COVID-19 pandemic will begin to recede, but in its aftermath, we'll have handed off many formerly human functions to agile robots. These will have been trained partially or entirely through reinforcement learning to flexibly navigate, manage and manipulate objects in complex real-world scenarios. Biosensing, delivery, and disinfection will become dominant robotics segments, with drones among the dominant platforms for which RL-based AI apps will be trained. Deepfake technology will infuse a new generation of AI-based media prep tools. Generative AI is versatile. In 2021, deepfake technology's generative adversarial networks, GANs, will prove their worth as enablers of composition and refinement of video, audio, and other media content through algorithmic manipulation. GANs will become standard tools for augmenting the verisimilitude of participants' presence in real-time virtual workspaces. Before long, no commercial conferencing solution will expose users to the quality issues that come from raw video and audio feeds that have not been smoothed and augmented through sophisticated AI. Quantum computing will find its first compelling AI application. Otherworldly AI is imminent. In 2021, the developer ecosystem that has sprung up around TensorFlow Quantum will have delivered at least one example of a neuromorphic cognitive model, adaptive machine learning algorithm, generative adversarial networking, or parallel training program that quantum co-processing platforms run faster than is possible with any entirely classical computing platform. As these results are replicated on diverse commercial quantum platforms, the commercialization of the quantum AI segment will begin in earnest. Startups will jump into this arena and more enterprises will start to factor quantum platforms into their AI and high-performance computing plans in earnest.